Hi guys! So we're here at Logic Peak Open Space where we've been, and the purpose of this video is to show you how to quantify tree density in a forest. And so we're going to use something called the point quarter method. And here we have laid out two transect tapes, which are each 20 meters long, and they dissect each other halfway in the middle at 10 meters. And this is a good way to determine, using a random sample, determine how many trees there are in a forest by taking some samples and then scaling that up to the full forest.
Yeah, so it's really impractical and also impossible to go around an entire forest and measure all the tree density. So here we just have a little sub-sample of the forest, and we'll do some calculations later in order to scale this up and be able to calculate the tree density of the forest. So as you can see, we have these 4 quarters here. So in order to take our random sample, we are going to measure the distance from the center to the nearest tree in each quarter. And it's important to know that you should be sure to define what makes a tree, what defines a tree in your study. So in our case here, we're going to define a tree as having a DBH of 1.5 centimeters and being 2 meters in height. So for example, this tree here, we've measured the DBH and it's 2 centimeters. We have to double check the height to make sure it's 2 meters, but I'd say it's probably about 2 meters tall, in which case if it is, it would be a tree. If not, we'd have to find the next nearest tree in our quarter.
Hello, so here we are again, trying to do the point quarter method to measure tree density, and we had to take up one of our transect tapes because we don't have enough. So now the water bottle there is our center point marker, and we're going to take measurements from the closest tree in each quarter to the water bottle, or the center point. So we'll start off with this one, and we're going to measure from around DBH, just to keep it consistent. I'll start here, and then Olivia will take it to the center.
Yeah, that's important to make sure you keep your transect flat so you don't get an inaccurate reading. So here at the center point, we are at 4.3 meters.
Okay.
4.3 meters. Okay.
So
So next quarter.
to your next closest tree in the next quarter. Okay, so here we are taking the next measurement for the tree.
Yeah. One other thing to note is that we're keeping the end of this this transect kind of in the middle of this tree, and we're going to be walking out towards the center. So it's really important that you just to standardize everything to keep the end of the tape in the middle of the side of the tree that you're measuring away from. If that makes sense.
Yep.
So we're going to keep it really flat again and walk out towards the center. And here we are. This is at 5.3 meters.
5.3 meters. Okay.
Next quarter.
And keep in mind, people who are watching the video, we are in a part of the world where tree density is not very high. Imagine if you were working in the Amazon, right? How this method would look differently because you have trees, so many trees. So this is a relatively low tree density. You could gather that just common sense by looking around you, but also these numbers would confirm that.
So this is 5.1. I would go and just double check the ponderous line next to you to see if it's any closer. Yeah, so this is 5.5. So that's the tree that this smaller ponderous line is the one that we will use in the transect or in this quarter.
Okay.
Okay, and then for this quarter, this again comes back to the idea that you have to classify which size of tree that you're going to use as an actual tree. So this one has a pH of larger than 1.5 centimeters, and it's taller, just over 2 meters tall. So we're going to classify it as a tree, and we will use it as our closest tree.
Almost stepped in too. What's that?
And here we have 4.3 meters.
Okay. So then you would use those numbers to calculate the tree density of the forest along with some other samples. And yeah, I hope that's helpful.
Hey guys, now I'm going to show you how to do the calculations for tree density based off of the point to tree distances that we measured out in the field. It's important to note that normally when you're doing this, you need to have multiple samples, so you have more accurate calculations based off of a larger sample size. In our case, we only took the one, so this wouldn't be accurate in real life. Also, when you're doing this for your research in the field, it's also important to remember to make sure to randomize your areas so that there aren't any biases. So just using the numbers that we got in the field, the first step is to calculate the mean point to tree distance. So obviously we got these 4 distances in each of our quarters, and so we're just going to calculate the mean by adding them up together, dividing by 4, and we get 4.75 meters. So that is our mean point to tree distance. So after we get that, we're going to calculate the density, and in this case we're looking at the density of all species, because in our example we didn't distinguish between different tree species, but in your study you might be looking at the density of ponderosa pines, for instance. So it would be important in that case to make sure that you record the species of tree, or you can also calculate density, looking at one specific species or something like that. So in that case you look for the nearest tree of the species you're examining. But so in our case, for the density of all species, we're going to use this formula here. So density is equal to 1 over the mean point to tree distance squared. So we calculated the mean point to tree distance as 4.75 meters in the last slide. So 4.75 squared is 22.56. So 1 divided by 22.56 is 0.04. So that is our density in trees per square meter from our example. You could also multiply this by 100 to get the number of trees per 100 square meters if that's what you're looking at, or if you multiply it by 10,000 you could get the number of trees per hectare. In this case it would be 443 trees about. You can also, there's some different formulas to calculate other things related to density depending on what you're looking at. So one example is calculating the relative density, where you could look at the number of individual species compared to the total number of individuals of all species. So yeah, I hope this helps, and hopefully you guys learned some things from this video.